All right, so we're taking what we learned in 2.5 and kind of adding a little bit more to it. So now instead of variables just being on one side of the equation, now we're going to have them on both sides of the equal sign. So this is where drawing the river is perhaps the most important time to draw that river. Okay, so that's terrible handwriting. So draw your river. Then after we draw our river, we want to get all of our constants, all of our single numbers on one side. So we want to get our constants, in case you forgot, those are numbers, on one side. Doesn't really matter what side. I normally put it on the right side of the equation. The next step, so once we get all of our constants to the one side, preferably the right, then we get everything with a variable onto the other side, aka the left side. So we get all of our variables onto the other side. Okay, and again, that would be the left side. Okay, and then our plan is to solve, obviously, for the variable. Okay, so but before we can get everything to one side, we still need to, sometimes distribute or combine our like terms, okay? So those are still valuable resources to have. They're just not steps that each time, because those are steps that should be intuitive at this point. Okay, let's look at example 1. So our first step is to draw the river. And then, as I said, I normally get my x on the left and my numbers on the right. So I'm going to put everything with an x on the same side and everything with a number on the same side. So I'm going to move this 10x to the other side. And I'm going to do that by subtracting 10x because this is a positive. So I still have to do the opposite operation, which is to subtract. And those cancel. So 3 minus 10x is 7x. I still have this 10 over here, so bring it along. My equal sign gets brought down. It's equal to negative 4. Now I need to make this 10 go to the other side, go to the right side. So the opposite of a plus 10 is subtracting 10. Okay, so on the left, I'm left with 7x is equal to, and on the right, I have negative 14, if you plug that into your calculator. Now I have 7x is equal to negative 14. So now hopefully we know we just divide both sides by 7, and you're left with x is equal to negative 2. Okay. So again, we drew the river. We have to get everything to one side of the river and everything to the other side of the river. Okay, on to example 2. Okay, so you draw the river. Okay. Now, the first thing that I need to do here is to distribute that 2 into both the x and the 6. So 2 times x is 2x. 2 times 6 is 12. And I bring my plus sign down. And then equals 6x. Okay. So we want to get our x on one side and our numbers on the other side. So I see on the right there's a lone variable, and on the left, there's a variable and a number and a constant. So to simplify things, I'm going to get my variables on the right side this time. So I want my x on this side, I want my x on the right, and my numbers on the left. Okay, so in order to do that, this is a positive 2x. So the opposite of a positive is a negative 2x. So I'm doing a negative 2x to both sides. On the left, they cancel out. And I'm left with 12 equals 6 minus 2 is 4x. And then I have to get my x alone. So I divide both sides by 4. And then x gives me 3. Okay. So I want you to try example 3. So the only thing that's really the difference here is that there's some fractions, which if you're using a calculator, it should be no problem that there's fractions. Okay. So pause and try this one on your own. Okay. Okay, to sum this up pretty quick, I drew the river. I'm getting my x's on the left. So my x on the left, my numbers on the right. So I subtract 2x from both sides. I'm left with 5.5 plus x equals 4.5. I want to get my numbers onto the right, so I subtract both sides by 5.5. I'm left with x equals negative 1. Okay? So hopefully that's what you did. You subtracted 2x, moved it to the left, subtracted 5.5, moved it to the right, and you should have gotten x is equal to negative 1. All right. Looking at example number 4. Think about, after we draw the river, what do you think should happen in this problem? What do you think should happen? I see 2 distributive properties, and that's the only thing that's different. Now there's the distributive property on both sides of the equal sign, which is not really a big deal. Okay, so distribute the 6. You should get 6x minus 6 is equal to 9x minus 36. And now this is something just like example number 1. So I'm going to pause, and at the end I'm just going to put the answer. So I want you to figure out the rest of it. Okay. All right, so you should have gotten your x's on one side, your numbers on the other side, and when you did that, you should have gotten a positive 10. So just be really careful, look at my work, see where you might have went wrong.